Hey guys, what's up? So, my name is Hector Camacho. I'm a mechanical engineer student at CETIS Universidad here at Mexicali. And today we're going to be working on some pattern workshops, which are workshop number 5 and workshop number 6. We're first going to work on the creating our frame surface in workshop number 5. And after being done with that, we're going to hop on to workshop number 6, in which we're going to analyze it by creating a mesh and different stuff. And that's basically it. So the first things first, we got to create our folder. So as you can see, I already created mine, which is called frame underscore serve. So we're going to open that one up. And as you can see, I have already two things on here. The first one is an IGS file, which the workshop already includes. So the only thing I did was copy it and pasted it here. And the second thing is a pattern shortcut. This thing I only did it because Patron creates so many files that if you create a shortcut to here, the only thing you do is it helps you organize all your stuff and what you're doing. So we're gonna click on Patron and open it. I already have it open here, but so once it opens up, we're gonna go ahead and click on menu. Okay, and so once we click on menu, we're gonna go ahead and click on file, new, and we're gonna click on desktop, and we're gonna look for our file that our folder that we previously created, which in my case is this one. We're gonna double click on it, and we're gonna put a name on our work that we're gonna be doing today. So in this case, I'm gonna call it workshop underscore 5. And just go ahead and click OK, and everything we work on is gonna be saved on that folder itself and nowhere else. So we just wait, and once it opens up and we have pattern ready to work, we're gonna work with the tolerance of default. We're gonna check that this is MSC Nastran, and the analysis type's gotta be structural. We then click OK, and the first step we're gonna be working on is creating our geometry. So for that, we go to the geometry tab, and over here on where it says action, we're gonna leave it as create. On the object, the thing we're gonna create is a surface, and the method we're gonna be using is XYZ. And so we're gonna be using it as vector coordinates, and so on the x coordinate it's gonna be 24. On the sorry for that, it's gonna be 24. On the y direction it's gonna be 10, and the z direction we're just gonna leave it at 0. And then we go ahead and click apply, and that's it. So now we've got our first surface created. And so next we're gonna be creating our second surface, but this one's not gonna be by an XYZ method. This one's gonna be an extrusion. So we click on extrude. We leave everything as is except for the translation vector. On X it's gonna be 0, on Y it's gonna be 0, and the Z it's gonna be a value of 2, since in that's where our extrusion it's gonna be done on. We leave everything else as is, and we turn off auto execute, since we don't want it to, well, as the name says it, we don't want it to auto execute by itself when we are not ready for it. So we click that one off, and the curve lifts we're gonna be working on is the top one. So we click on it, and we click on apply. So we just rotate it so we can see what we just created, and it's this one. Alright, and so next things next. So we have created our second surface, which is this one, and we can label it by going to the home tab, clicking on this little L shape, which is of label control. We click on it, and then we select this one, which is surface. We click, and as you can see, it tells us the number of the surface we're working on, or we could be clicking on. So we're gonna create the opposite of the second surface we just created. And so we leave everything as is The only thing we're going to be changing is this 2 on the z direction for a -2. So we click on apply, and there it is. We just created the opposite of this one. And now that we have a complete side of the frame, we can go ahead and here on the same tab as where it says action, we just click on transform. We leave it as a surface, and we're gonna be translating it, and we leave everything as is except for the direction of the vector. On the x it's gonna be 0, and on the y direction it's gonna be -10. So for this case, only for this maybe for some others too, but for this one in particular, we're gonna leave auto execute on, and I'm just gonna go ahead and the surface list. I'm gonna click on surface number 2. There you go. Just created number 4, and I'm gonna click on number 3, and there you go. Just created surface number 5, and so now we have 2 sides of our frame. Now we're gonna be creating a copy of all of this frame that we've just created so far. So to do that, we're gonna leave or stay as it is as an action of transform, surface, and translate. And as I mentioned, everything stays as it is except for the direction of the vector. Now on y it's gonna be 0, and on x and on the x direction it's gonna be 24. So we're gonna leave auto execute on, and on the surface list we're just gonna select, or I'm just gonna select the whole thing, and there you go. It just copied everything and it just moved it to the right direction. And so after creating our copy to the right hand side of our original frame section, we're gonna create 4 points which are gonna function as a origin, so we can create some circles on our frame. So on here when it says action, we're gonna go ahead and create a point. On the method it's gonna be extract, and so we're gonna out of these 3, we're gonna be using the middle one, which is a point on a surface. We're gonna be working on different values on the parametric position little window here. So we're gonna leave the bottom one as it is at 0.5, but the top one we're gonna work it as a 0.25. And the surface list we're gonna leave it at auto execute, and the surface list is gonna be on the first surface, and we're gonna on the 6th surface too. So as you can see, we have 1 point here, another one here. Now we have to create 2 other points, but at a different distance. As I mentioned, we're gonna just change the top one for 0.75. The bottom one stays the same. And on the surface list, we're gonna click on the first surface and on the surface number 6. Since it's in auto execute, it just created 4 points that are gonna be critical for us and simplify in a way our job for creating some circles. Okay, and so now we gotta create our first 2 circles. For this, we're gonna leave it as the action create. We are gonna create a curve, and it's gonna be a 2D circle. And so for this, we're gonna leave the input radius 2.5, and we're gonna take auto execute off, and the center point list we're gonna erase it, since we're gonna be using the points we previously created. So at center point list we're gonna use that one, and we just click on apply. So we gotta erase this one, and then click on our second point, just click apply. And so that's gonna be it for our 2 first circles. Okay, and so next thing we gotta do is we gotta extend our surfaces, and for that we gotta go to edit, and we click on edit. We're gonna edit a surface, and the method we're gonna be using is extending it. these options, we're going to be using this one, the last one, which is a fixed length. We click on it. We're going to be using this one, the first, which is all associated. We click on it. Our length, we're going to put 2 on it, and it's very important that we take auto execute off. And we're going to select by clicking shift. We're going to select various elements of our drawing. So we click that one, this one too, this one, and this one, the eye looking letter. So we have it like that, and then we click apply. And now they're all extended. And after creating that extended surfaces, we've come to a breaking point, like literally. We're gonna leave it as edit surface, but instead of extending it, we're gonna break it. So the surface ideally doesn't really matter. We just gotta make sure it says curve. Delete original surfaces, we're gonna leave it on, but we're gonna turn off auto execute. In the surface list, it's gonna be our first surface, and the break curve list are gonna be our 2 circles right here that we created. So we select the first one and the second one using the shift key, and then we just click on apply. This dialog box is gonna pop up asking us if we wish to really delete the original surfaces, and well, we just go ahead and say yes. And now, since we all know these 2 circles are gonna be holes, we can delete like the surface of it. So we just go here, instead of edit, we delete, and the object, it's gonna be a surface, and the surface we're gonna be selecting is this one and this one. Remember using the shift key. So there you go, you have those 2 to erase the surface. You apply it, and there you go, they're gone. Now they're completely holes. Okay, and so up until this point, we've created 2 holes on surface number 1. What about for surface number 6? So for that, we're gonna go into into edit a surface, and instead of break, we're gonna add a hole. Like, this is way easier than the process we already went through, but I mean, just gotta know your options. So it's gonna be the same radius, 2.5. The surface we're gonna make it on is the surface 6, and the certain center point list is this one and this one. So we just click apply, and there you go. You just created 2 holes, like in 2 seconds. And so, well, now the thing we gotta work on, or the thing we gotta do, is we gotta transform our surfaces. And so for that, we go here to transform a surface, and the method's gonna be translate. So we leave everything else as is. As we can see here, everything just stays the same, even the direction of the vector. The only thing we're gonna be changing here is the translation. This is how many, like in simple words, how many things you want to copy. So we go ahead and just put 2 on it, and we're gonna use a different tool this time. We go ahead and click on preferences, and we're gonna go ahead and click here on peaking. And the only thing we're gonna check is that enclose any portion of entity is selected, which is here, and it is. So if it is, just go ahead and enclose it. And on the surface list, we're gonna leave auto execute on, and we gotta be careful because the thing we're gonna be copying is this one. So we just select it like this, and there you go. You just created the translation of your different I-beams. So this next step we're gonna be doing is just to make things easier for us. We're gonna go here to display and click on geometry, and the thing we're gonna be changing is our point size. So we see here it's a 4. You can just go ahead and leave it as point size. I'm sorry, it was a 1. Now we want to leave it at 4 so we can just see everything clearly. We click on apply, and there you go. Those points are bigger. We can even make them as 5 if we want to. but we'll just leave it at 4 for now. So we click apply, and yeah. So next thing we're gonna be doing is we're gonna go here on geometry again, and we're gonna be working on transforming. We're gonna be working on some points, and the thing we gotta do is we're gonna leave action as transform. So we leave object as a surface, as where it says surface, we change it to point, and the method's gonna be translate. We leave everything else as is. The only thing we're gonna be changing is the direction of the vector. Instead of 24 in the x, we're gonna be using 4. The translation this point is gonna be 1, and we turn off auto execute, and the point list, we're just gonna be translating one single point, which is gonna be this point 26. We click on it, and then we click apply, and as you can see, it just created another point right next to it. That's basically what we wanted it to do. And so uh, yeah, that's it for this part. And now we're gonna create another a plane using this point as a reference. So we go ahead and click on action, create, and the object, as I told you, it's gonna be a plane. And the method we are gonna be using is a 3 points method. And so in order for us to create that plane on 3 points, we gotta turn off auto execute, and we're gonna zoom in here to this part. And the first point we're gonna be working on is this one, which is point 27. The second point is gonna be this one, the middle one. No, I'm sorry, this point's not the middle one. It's the one we just created, point 49. And the third point of on our list is gonna be the little one in the corner, which is point 30. And after we've created that, after we selected that, we click on apply, and as you can see, we've created a plane that it's over here. And the next step to do is, and so now we've come to our second breaking point. So we're gonna go here where it says create, we're gonna edit a surface, and we're not gonna be adding a hole, we're gonna be breaking something. And so this time, instead of having a curve, we're gonna be using what's called a plane, because we've just created one. So we're gonna turn off auto execute, and we're gonna leave the other one checked. And the surface list we're gonna be working on is the 13th section. So we're gonna select it like up until here, and there you go. It's 2 to 5, and the surface number 13, which is this one. And the break plane list is gonna be the one we just created. So we click on it, and then we click on apply. It's gonna pop up another dialog or a text that is saying if you wish to delete them, and it's gonna be a yes for all. And as you can see, it's given us this result. And so the next thing we're gonna do is we're gonna delete all these leftovers, just to call it some way, because we don't really want them, because since we've already cut them, like they are already cut, but they haven't been deleted. So we go over here to delete. We're gonna delete a surface. We turn, well, auto execute is off, and by using the shift key, we're just gonna click on 26, 24, 30, 28, and 32. So we've already selected all of this, and we just click apply, and they all turned black, because turning black means they have already been deleted. They don't appear anymore, but if we wanted to see how, or to refresh our graphics, we go over here to this little brush, we click on it, and it refreshes it. And to see how we're going, how we are doing so far, we just go to this smooth shaded box, we click on it, and this is how we're doing so far. This is the original part, and this is the 45-degree kind of cut that we've made. And yes, so this is what we have been working on. So let's just continue to the next step. And so now we're gonna be working on transforming this again. And by transforming, I mean we go over here on the action, and we select transform. We're gonna transform a surface, and we're gonna translate it. We're not gonna translate it, we're gonna mirror it. So here on mirror plane normal, instead of 0.3, we're gonna select 0.1, and the offset on this one's gonna be 60. So we erase that and we put on 60. We turn off auto execute, and the surface list we're gonna be working on is this first one where the plane is. We select it up to here. As you can see, it is right there selected, and we just click apply, and there you go. Has the same 45-degree angle cut, and now the only difference is we have a total of 5 I-beams, which, I mean, in conjunction they all make a whole I-beam itself. And so now the thing we gotta do is say goodbye to this awesome little beam we just created, because the workshop tells us in order to save time and not to be so long, we have to open up the IGS file it already gave us. So just to keep it, we're gonna go to menu, file, and we're gonna save it. Once we have saved it, it's gonna be on our folder. So we go to file, and then we close it. Once we've closed it, we go to menu, and we're gonna create a new working space. Okay, and so once we are here to open a new database, we're gonna do the exact same steps. So we're gonna go to our folder, we're gonna open it, and we're gonna erase all of that it's here, and we're gonna call this whatever we want to. So it can be workshop underscore part 4, or maybe part 2. I'll just leave it at part, workshop underscore part, and we're gonna click on OK, and we wait till it opens up, and once it does, we're gonna click on default, MSC Nastran structural, we're gonna click OK. And the next thing we're gonna do is we're gonna go here onto menu, onto file, and we are going to import the file that workshop gives us in the beginning. So we go here to desktop, we go to our carpet, and as you can see, there's nothing. We need to change the source to the one the file is in, and as you can see, there it is. We need to check that the current group, the ones it's gonna go into, it's default, and we need to uncheck the import to solid one. So we uncheck that one. We make sure we select this one, and we click on apply. We just wait a little bit till it opens up. Once it does, it's gonna give us a summary report or import summary about the beam we just imported into Patron, and it's this one. So you can remember we already made a whole side of it, but to save time, the program or workshop gave us the whole thing. So the next thing to do is, and so I forgot to tell you guys, this import summary report is gonna pop up. It's got info about the piece you just imported, but I mean it's important, but for us we're just gonna click OK on it. And the first thing we're gonna do is we're gonna go on here where it says group, and we're gonna click on modify, because we gotta make sure we're working on the correct group. So on here on modify, we're gonna be on rename, and we're gonna rename it as all underscore surfaces. We click OK. We see that it changes right here, and so we just go down and we just say click OK. And the next thing we're gonna do is we're gonna begin to mesh. And so the next thing we're gonna create is the group we're gonna be working on, since we delete the other one or we changed the name on it. So we go to group, we click on create, and we click on new group name. The new group name, you can call it whatever you want. So this one I'm gonna be calling it my name, as in Hector. On you can call it whatever, as I said. I'm just gonna be Hector, or maybe just Ec underscore surfaces, and we gotta make sure we make current. So we make it current, and we just click on apply, and then we click on cancel. And so in order for us to start working on our mesh, we go here with the meshing part, And so as I said, we need to create the mesh for our beam or for our frame. So for this, we go to create, we leave it as create. The object we're going to be creating is just a mesh, and the type is a surface. We leave the element shape as a quad, and the measure we change it to a paver. And the topology, we're just going to leave it at quad 4. And the surface list, in this case, we're going to be selecting the whole entire thing. So I'll just go back and we go like this. There it is. Just selected everything. So and for the purpose of the workshop, it tells us to put this at 1, but since we're working with the student version, it tends to crash when you put 1 on it because it's happened to me. So I'll just leave it at 2 since that one will work with me. And I mean, after doing that, the only thing that's left for us is just to click apply and wait a little bit, and it starts creating. Just give it a second, and there you go. The mesh is created for your frame. And so our mesh is created, and you can see it right here, like on the top. It's like perfect, just per se, and you can see how the smaller cubes adapt to the circular shape of our beam. And so now we have to do is we've got to work with equivalence. So to do that, we go here to instead of create, we go here with says equivalence. The object's gonna be all because we're gonna be working with all, and the tolerance is gonna be cube. This value is predetermined. I'll just leave it like that, and the only thing left for me to do is to click on apply. And as you can see, it like just worked every single node on it, and made it in a different color so you are able to see it. So you can see like every single node is has a purple circle on it. And yeah, so we gotta work on our next thing. And so now, since we're done with our equivalences, we go here to our action tab, and we're gonna click on the verify tag, and the object's gonna be the element itself. I mean the whole thing we're gonna be working on, and the test is gonna be the boundaries of the free edges. We click on apply, and as you can see, everything is perfect. The beam looks like it should look like. There's no problems with it, and it just works flawlessly. So the next thing we're gonna be doing is we're gonna be verifying, but not the element itself, but the quads, the nodes, to see if they are all working properly, and we're gonna be looking at the aspect of them. And so uh, we're gonna go down, and you can see the aspect ratio. You can change it. We're just gonna leave it as at 5 if I can right here. It's a little bit tricky. Maybe if I go back, oh, there you go. 5.1, no, I just want 5. What happens if I go back? Okay, so we want to leave this at 5. So yeah. And so once we got the aspect ratio at 5, we just go ahead and click on apply, and it's gonna ask you this dialog box. You just click OK on it. And as you can see by the color sequence right here on the right, uh, all of our quads are perfect since the color maintains the same all around the shape of the frame itself. So what we're gonna do next is we're gonna post it. So we go here to group, post, and we select all surfaces, and we select apply. And as you can see, this one is the first thing we worked on, the frame, bare naked if you want to. And we click on cancel. And so after this, what we are gonna be working on is the loads itself. So for this, I'm gonna zoom into this corner. I'm gonna go to home and put the smooth shaded on so it can be better to identify. Now just go to loads, the tab, and force. So we gotta create a force, right? So we go on to set a name first, and I'm just gonna call it load_1, and we go to input the data of it. And so the workshop gives us the value, so we go 0 on x, minus 150 on y, and 0 on z. And then after that, we just go ahead and click on the OK button, and we then select the application region. And after selecting the input region, so we have the data on it. Now we gotta select where we want the force to be applied. So we go ahead and click on geometry entities, and we're gonna click on this point right here, which is point 3. We gotta zoom out and then zoom back in to this point by clicking the shift button, which is point 60. So once we have those two selected, we just click on add and OK, and we just click on apply. Since we have our force load and our application region in the name, we click apply. There you go, 1.50 plus O2. That's the 150. This is just another way to express it. And we have them on the both sides. And so then we move on to our next point of application, which is going to be these 2 points right here. But first, I mean, we have to, okay, so we have our axis right here. We move on it, we zoom in, we zoom out, whatever, we rotate it, and from this side, we move on to this side. We gotta apply another force. So this one's gotta be number 2. So to input the data on it, we gotta go to input, and x stays the same. It's 0. The one that changes is the y, which is 960. And so after applying that, we just go and click OK on it, and we go to the select application region. And again, as I mentioned before, we select the geometry entities, and we go ahead and select this part, these 2 points right here. It's gonna be this one and the other one, as it was on the other 2 points before. So we just go ahead and select this point right here, and zoom out and zoom in again, and click on this point right here, which is 37 and 80. We zoom out and we click add. Okay, we have a name, input that in application, we select apply, and there you go. Now we have both of our forces or loads. So I thought we were done, but we have to create a third load, which we are gonna call load underscore 3. We're gonna input the data on this one, and this one's gotta have minus 100 on y, and the same thing goes with z. And so we just click OK, we select the application region, and it's gonna be the same 2 points we previously selected, and we just click on them. It's 37 and 80, add, OK. We have everything in order. We just click apply, and you can see how the value changes. That's because they are adding up. And yeah, I mean, that's basically all the loads we're gonna be applying. And the next thing we're gonna do is create an inertial load. So we just go here to where it says create. The action, we leave it the same. This time we're not creating a force, we're creating an inertial load, as I said. And the next thing we got, we gotta make sure it says element uniform, because we want the load to, or the inertial load to be expelled uniformly all over the frame. And we just, this one, the workshop tells us to call it gravity, so we're just gonna call it gravity. And the input data on this one's gonna be similar to others, but not the same. So it's gonna be 0 on x, it's gonna be minus 386.4 on y, and it's gonna be 0 on C, and we just click on apply. I'm sorry, we just click on OK, and now we have to create. Now that we have clicked on OK, we have to create to select the application region, and so for that we have to. Now we just click on apply, and as you can see, there's our force being applied over here, and now we just have to take our next step. Okay, so now that we have our gravitational inertial force being applied on our frame, we have to fix our frame, or condition our boundaries per se. And so for doing that, we go ahead and click on loads, on the loads tab, and on displacement constraint. We are gonna create a displacement, and the type's gonna be nodal, and the name we're gonna put on it depends on us, really. So the workshop tells us to call it fixed space, so that's what I'm gonna call it. And now we have to just input the data on it, and since the only thing we really wanted to do is to really not to do anything, so we're just gonna put 0 on everything, and we are going to click on the OK. And so after clicking OK, we click on the application region. Since we are already in wireframe view, we just have to select every single corner we want the force to be applied on. And so for that, we go ahead and select this little point or vertex, and we zoom into the corners. So that's 0.90. We go ahead and select this one too by clicking on the shift knob. 0.90, 0.1. It's 0.98. And last but not least, 0.52. We go ahead and add them, and we click on OK, and then we just click on apply, and as you can see, every single corner is now fixed to the ground. And then, just to make things a little bit easier for us, we're just gonna go ahead here and click on this little icon which says fit view. We're already on it, so just go to display, load, and constraints and everything. We click on it, we go to this little tab which is clicked, we unmark it per se, just to make things a little bit easier for us. We apply it, and as you can see, everything's like clear now. It's easier to work with. Just go ahead and cancel that, and now we have to go input our material for our frame. So we go to properties, and we go to isotropic, and the next step to do is, so once we click on isotropic, it's gonna pop up this window out of the right corner. The material name we are gonna be working with, it's aluminum, so I'm gonna put aluminum on the material name, and I'm gonna input the properties of it. As the workshop tells us, the elastic modulus of it, it's 10 exponential 6. The Poisson ratio of it is going to be 0.3, and the density of it, it's going to be 2.61 e to the -4. So we just go ahead and click OK on that information, and we apply it, and as you can see, it appears right here as an existing material already. And so once we have inputted the material that we are going to be working with, we have to literally insert it into the program so that it recognizes that the frame itself it's made out of that material. So we go onto the properties tab, and we click on this one that's called shell. So we click on it, we create a 2D shell, and we set a name to it. and the workshop tells us to call it all underscore frame underscore flange. All of this because the flanges of the frame are of different thickness than the middle part of it, just per se. So the input properties of it is gonna be the material name. We click on this little like uh, mm, ma- uh, little button right here. We click on it. We click on aluminum. That's our material, and the thickness of it is gonna be 0.75. And so once we've inputted that into our thickness, we just click OK on it. And we need to select the application region. And so for this, we just select the flanges of it. And so now we select the application region for the oh my god, I forgot what to call for the shell. And so in this case, as I told you, it's for the flanges. And so we only need to select the flanges and nothing else. In order for us to do that, sorry, and not to do anything else or messed it up, I'm gonna go ahead and click on home, click the front view, and go here where it says viewing. I'm sorry, where it says preferences. I'm gonna click on picking, and on the rectangle polygon picking, we're gonna click on enclose entire entity. We're gonna close it, and the select members, we're gonna choose only the top and bottom flanges. So we're gonna go like this, very careful. There we selected the top part, and now we select the bottom part of it by clicking on the shift. I forgot to click on shift there, so there you go. So we click on add, we select OK, and we apply those. So once that we have those applied, we now have to put on uh, the the shell, but not for the flanges, only the frame. So we gotta change the name. And so the next step to do is to get rid of the peaking we just chose. So we go ahead and click on enclose any portion. We close it, and we now need to put the new property set name. So we're gonna go like all underscore frame underscore web. We're gonna input the properties of it. The material, it's gonna be aluminum, and the thickness is gonna be 0.5. We OK it, and the application region of it is gonna be in between the flanges. So it's this part of right here. We add those, and we OK it, and we apply it. And that's it. Now we have our flanges and our web with their properties, their own material and thickness. And so the next thing we gotta do after just creating the all frame flange and the all frame web is just check if our load cases are all correct. So we just click on those, click on default, and just see. So we have a fixed base, 3 loads, and the gravity one. So everything checks out, and we can just OK it. And so since that's alright, we just go ahead and click on group and post. We now need to post our hex surfaces, or are the workshop tells us to call it the FEM surfaces. We click on it, we apply those, we cancel those, and we just go to home, change our view, and fit to view so we can all see it better. And we can see that the corners are all fixed and that everything's working all right. So now what we have to do, and the only thing rest to do, is to analyze it. So we go to the analysis tab, and we go to the actions analyze. We're gonna analyze in the entire model, and we're not gonna make a full run. We're just gonna make an analysis deck, and the next thing to do, I mean the job name, it's gonna be the one you put on it, and the next thing to do is, and so as I said, we have our job name, which is the one we've established before. We go down, we make sure our solution type is linear static, and we click OK, and then we go to translation parameters, and the card format is gonna be a small. So we leave everything else as is, And since everything looks good to me, job name, nice tech, tire model, we just click apply, and there it is. It just created a format that we're not able to view it right here. But if we change our to the next window, we were gonna be able to. And so once we've clicked on analyze, we can just minimize this window and go to our folder where we previously had patch only two files on it, and we search for the PDF file. In this case, I have it on Notepad, so I double click it. It opens up to this. It tells us every little piece of information we planted into Patron, like the P shell and the every single C quad. It originated, the identifier number, which is 1. We can go down and we can see here we can see PCL number 2, like identity number 2, and the sequence it created, and every single step that was taken, like the material which was chosen, the name of it, the thickness. We go all the way down, and we have the forces, the displacement, the gravity. Every single thing that we have done up until this point is recorded here on our notepad. We can close this window down, and we can go ahead and open Nastran. So we double click on Nastran to open it up. We go to our previously made folder, double click it, and we have our workshop, our BDF file. We open that one up, we click on run. We let Nastran do its job. You see files appearing over here, and the way we can know that it's finally done or over with it, it's by just it's when this window disappears. It's that Nastran has done its job, and we have finished. We have kind of finished um, with our job here. So as you can see, it disappeared, and the files are getting less and less. So this is our final product. We have an XDV file which we are gonna open up later in Patron, but for now we can open up our FO6 file. We double click it, and it's gonna be this one. Is like this one will display every single thing we did, every node, every C quad, every displacement, every force, everything will be right here. And the most important thing about it is if we click Control F, or we search for something, like as in we're gonna be looking for fatal, the word fatal, and it didn't find anything, so that's perfect, because if it did, it would mean that there's something really bad with our program and we need to do it again. And the other word we're gonna search for is warning. So it find one, which is the one at the beginning, which really doesn't matter to us, and it didn't find anything else, so we're cool. So we can just close FO6 file, and this one, the XDB, we're gonna minimize this window, open up Patron again. We're gonna click XDB. We're gonna go down and select results file. We're gonna select the XDB, which is already in our folder. We're gonna click OK. It's gonna import right here, and we just click apply, and we wait. And lastly, since we go to the tab of results, since we've already imported the result itself, we go here to deformation to see what the deformation of it was. We go to displacements translational, and we click here on where it says display attributes. The scale factor, we want it to be 0.01 instead of 0.1. We don't want it to show us the undeformed part of it, and we just click apply. And as you can see, there's a slight deformation on the center part of it, more to the right. It's not perfectly rectangular anymore. It's not a straight line. It has a curve on it on the right side. I don't know if you guys can see it. And if you can't, we can just go ahead and click on the attributes again. Instead of wireframe, we can change it to shaded and leave everything as is, and we can click apply. And I think that's way better to see, way easier. We can see that there's a slight curvature on it on the right side of it. We can rotate it around and we can be able to see it. It's not straight anymore. And the other thing we want to really see is the stress on it. So we go ahead and click on fringe, and we want it to be again the displacement translation and the position. I'm sorry. The we click on the and so as I was saying, we go here to default. This one's just you just leave it like that. You go all the way down here to stress tensor since that's what we are looking for. You make sure it's positioned at C1 and that the quantity is at bond misses. You just apply it. And as you can see from the image, part of the biggest stress is focused on this region, and that's part of because the biggest forces are focused on this point and on this point. And so all the stress, or most of it, it's being focused on these two holes right here, and the biggest is on this bottom part of the last hole. And I mean, you can rotate it around and you can even see that it's the same on both sides of it, top, bottom. You can rotate it around as I was telling you, and you can see this stress here, I mean the biggest, and on the bottom too. So yeah, I mean, most of the stress we can see it focused on this part of the holes and on this part of the beam. And after seeing this stress being focused on this, we might as well just go ahead and see how the stress on each of the quads is acting. So we go ahead to home, we're gonna reset the graphics, and we're gonna focus the fit to view. There it is. And we're gonna create a marker. So we're gonna click marker, and I'm gonna create it as a vector, no, as a tensor, because we're gonna see how they're acting. So this stays the same. It's gonna be positioned at C1. We're just gonna leave the markers at XX and YY. So we're gonna do that. We're gonna check the attributes again, and in this one we're gonna unmark the show max min and the show tensor label, and we're gonna check too on the plot options, and we're just gonna leave it as is, and we're gonna click on apply. And whoa, man, this thing's just amazing. Like, if you see it from a distance, it doesn't look like anything, but if you see it up and close, you can see that on every single quad you're able to see the direction and where is the stress bigger, and on what direction is it going. So this is just kind of pretty cool to watch to the eye, and it's mesmerizing, and at the same time it gets you dizzy. So yeah. And now, just lastly, we're gonna reset the graphics again, and we're gonna go to the create marker tensor again, and the only thing that we are going to change is the fact that instead of an as is coordinate, it's gonna be global. We can just watch that and click apply, and I mean, it looks greener than the other one, but the only bird difference is that the plots or the quads that you see here are just on the MSC Nastran global coordinate system. So that's the only bird difference. Other than that, the stress tensors and everything, it's exactly the same. And so that's what gives us to our final goodbyes. It's been everything from my part. Hope you guys like it, and don't forget to share it, and please like the video because it's part of our grade. So yeah, thank you very much, and Last thing we're gonna do is just click on menu on the file. We're gonna save it, and once it's saved, we're just gonna click on the X. You sure? I'm sure. And that's it for now. Thank you guys.